Today we are talking about systems of linear equations. In order for us to start talking about that, we need a little refresher. So we're going to start on solutions to linear equations. So we're going to fill in some blanks. Think back to, and here we're going to put linear equations. Now we did these right before Thanksgiving break. Linear equations. And remember, in parentheses, I want you to put those are just lines. Linear means lines. For instance, consider the linear equation y equals 3x minus 5. A solution to this equation was any xy point that worked in the equation. So what does that mean, that it worked? Well, we're gonna find out. So 2, 1 was a solution because substituting 2 in for x gave us 1. Well, let's do that. We're going to take this equation right here, y equals 3x minus 5. And we know our solution is 2, 1. We know this goes x coordinate, y coordinate. So we're going to substitute 2 in for x and 1 in for y and see if it's true. So 1 equals, we're getting that 1 from right there, 3 times 2, we're getting the 2 right here, minus 5. Well, does 1 equal, 3 times 2 is 6 minus 5, 6 minus 5 is 1. So does 1 equal 1? Yes, so we know a solution to this linear equation is 2, 1 because this point is true on this line. So a solution for a single equation is any point that lies on the line for that equation, or any point that is true. You're going to hear me say that a lot. This point is true on this line, meaning if we put 2 in for x, we get y equals 1, and this point is 2, 1. Okay, so our first example here is, which of these ordered pairs are solutions of x plus y equals 8? And look at this hint down here. There may be more than one pair that makes the equation true. True, true, true. Okay, so let's try it out. A, we're going to put in 7 for x, y equals 1, and does that equal 8? So let's see, 7 plus 1, does that equal 8? Yes, it does. So this one is true. 3 and 11, we're going to put 3 in for x, 11 in for y. 3 plus 11, does that equal 8? No, that equals 14, so we know that's not true. What about 2 and 9? We put 2 in for x, 9 in for y. Does that equal 8? No, that equals 11. What about this one? 4 plus 4. Well, everyone right off the bat should know, oh, that is true because 4 plus 4 is 8. So these two are true. What does this mean? This means that 7, 1 and 4, 4 are points on the line right here, x plus y equals 8. Okay. Which ordered pair is the solution for the equation? So this one I want you guys to try. So I'm going to write you try. So pause here and see if you get the answer correct. Okay, so notice here it went y minus x equals 7. So here we put in 6 for y, 1 for x. 6 minus 1 equals 7. No, it equals 5. B was also not correct. C was our correct one because 6 minus a negative 1 is equal to a positive 7. Because remember, you change those both to positive. D was also incorrect. All right, another one down here. Now this one, I didn't want you to get thrown off, but it's basically the same thing. Negative 3x equals 2y. So you just do the same thing. For this one, you put in 1 for x, so negative 3 times 1 equals 2 times negative 1. Does it? Does negative 3 equal negative 2? No, that's not correct. Okay, so let's try this one here. 7 and 10. Negative 3 times 7. Does that equal 2 times 10? No, this is like negative 21. This is positive 20. So no, that's not correct. C, negative 3 times negative 2. does that equal 2 times 3? Well, yeah, because negative 3 times negative 2 is 6, and that equals 2 times 3. Does 6 equal 6? Yes, it does. So there's our solution. Just, I don't think this one is correct, but let's try it. Negative 3 times 5. Does that equal 2 times 5? Well, no, it doesn't, because negative 3 times 5 is negative 15, and 2 times 5 is 10. So there's that. So that, again, is just solutions to linear equations. We just want to keep that in mind when we talk about systems of linear equations. So next, systems of linear equations. Systems here, this word right here, just means more than one. So linear equations, we know are lines. Systems just means more than one at the same time. And you can see this example over here of more than one line on one graph. So a solution for a system of equations is any point that lies on each line in the system. So which point in these two lines lies on both lines, on each line? Well, it's this one right here. It's where they cross, because this point is on the blue line and it's on the green line. Okay, for example, the red point at the right here, is not a solution to the system because it is not on either line. This red point right here does not lie on the green line, and it does not lie on the blue line. But the point, and there's two blanks right here, so what point is this? This point is negative 1, comma, 5, right? Because you go over negative 1, down 5. So negative 1, comma, negative 5. That is a solution because it lies on each line. All right, so the point, it is true, negative 1, comma, negative 5 is true for both equations, for both lines, both the green line and the blue line. Okay, let's flip over our notes. State the solution to each system. So here we have a graph. We have a system. We have where they intersect right here. So the solution to this system is where this point is true for both lines. So what is this point? This point is negative 2 for x, negative 2, because remember we started the origin, we go over 1, 2, comma, 2. We go up 2. So the solution to this system is negative 2, comma, 2, because negative 2, comma, 2 lies on both of these lines. It is true for both of these lines. Okay, now this one over here. Where is our solution? Our solution, again, is where they cross. It's right here. You can dot it or circle it or both. Now, what is the coordinate to that? That coordinate is over 1, 2, 3. So the x is 3. And down 1, 2, 3, 4, 5. So that'd be negative 5. So over 3, down 5, 3, negative 5. So this is just something you could see by looking at it to see, okay, does this have a solution? Yes, because they cross. If two lines didn't cross, then there would be no solution. Okay, now we get into the algebra stuff of solving systems of linear equations. So tell whether the ordered pair is a solution of the linear system. So just how we did first, we put in 4 for x and 1 for y, and we tell whether this coordinate here is a solution to this system. This is just two lines. This is the first line, this is the second line. So let's put it in. We put in 4 for x. Maybe we could put that here. 4 equals x, 1 equals y. So 4 plus 2 times 1, does that equal 6? 4 plus 2 equals 6. So it works for this one. Yay! Now let's see if it works for this one. 3 times 4, because 4 equals x, plus y, does that equal 11? 3 times 4 is 12. 12 plus 1 is 13. And it does not equal 11. So this point right here does not lie on this line. So 4 comma 1 is not a solution to this system of equations. These two lines don't cross. So we want to put, let me change the color, 4 comma 1 is not a solution. All right, let's try this one here, negative 2 comma 1. So again, negative 2 equals x, and what equals y? 1 again. All right, so 5 times negative 2 minus 2 times 1, does that equal negative 12? 5 times negative 2 is negative 10, minus 2 equals negative 12. Yes, it does. Negative 10 minus 2 equals negative 12, so we are happy that one works. Now, let's try the second one. Does negative 2 plus 3 times 1, I almost put y right there, equal 1? Negative 2 plus 3 times 1 would just be negative 2 plus 3, and yes, that does equal 1, because 1 equals 1. So this does work. Negative 2 comma 1 works for both of these linear equations. It's true for both of them. So, in a different color, let's go ahead and write negative 2 comma 1 is a solution. All right, why don't you guys try this one here and this one here? Pause and see if you get them correct. I'll put up the answers in the work. We're saving the rest of this for tomorrow. So this is your notes page for today and tomorrow. So pause here and see if you get them correct. Okay, so you put in for this one here, you should have gotten yes, that 4, negative 3 is a solution. You should have put in 4 for x and negative 3 for y and gotten negative 18. That does check out because negative 12 plus negative 6 is negative 18. This one down here, you should have gotten 27 equals 27 because 24 plus 3 is 27. Now our next one, you put in negative 4 for x and negative 6 for y. And right off the bat in this first equation, you should have gotten that this point was not a solution to this equation because negative 12 plus 6 is negative 6 and we wanted it to be positive 6. So we already know, we didn't even have to check this second one. We already know that negative 4 comma negative 6 is not a solution. So again, we are leaving the rest of this for tomorrow. Use this on your homework for tonight, and if you have any questions, please ask us.